Hello and thanks for joining me. Today I'm going to be talking about Flitch Beams, what they are, how you can use them on your project and why you might want to, and how we go about modelling them in Revit. So let's get into it. Flitch Beams are timber beams with a steel plate sandwiched between them. So as you can see in this example, we've got two timbers with a steel plate in between. Sometimes you might have several timbers with several steels in between, but this is your typical configuration. The timber members in this instance wouldn't be strong enough to span this distance. So in our design software here, this is the Flitch beam configuration. We've got the two timber members with a steel plate in between, and you can see that this is all passing nicely, lots of green ticks. If you're not familiar, this is Tekla TED software. So with a 4 metre span taking some roof load, the two timbers won't be enough, which we can see in this demonstration here. So we use just those two timbers, so 250 by 47 timbers together. You can see that that's failing in deflection and it's failing in bending. If we put those two same timbers and then just have a very thin 8mm thick piece of steel in between the two, and you can see now lots of green ticks and it passes. So that shows how a Flitch beam can be used with minimal extra structure to provide actually a nice strong beam over a fairly considerable span. The other advantage is having a number of small elements. For instance, in a loft conversion, you'd be able to manhandle these up into a fairly awkward space much easier than if it was just one solid steel beam. Another advantage is with the timbers being either side, it makes it a lot easier for the builder to fix new joists or rafters, whatever it is, which are likely to be in this kind of construction more timber elements or framing elements to be fixed into the side of the timbers. So how do we go about modelling this in Revit? So this is how I model Flitch beams. In a plan view, I set a grid line on the centre of where the beam is going to go. I select reference plane and I draw in reference planes at either end of where the beam is going to go. And then into the structure tab, you select beam, and now I've already got the members that I want in here. So for instance, you might want to take, well, let's make it the same as the design example. So rather than this, let's go for duplicate. Never just rename it and change it, always duplicate, because you might have other areas where that same structural family is being used. So it was a 47 by 250. We can change that in here, 47 by 250. And then there's our timber beam. Okay, and we will draw this. If you snap it onto the grid line here, what we'll actually do is align. So you can either go to modify and align or use the shortcut you see there, AL. So that's what I'm going to do. So AL, select the reference plane and bring the timber end there and lock it onto that reference plane. And then the same here, select this end, reference plane, align, AL, and lock it onto there. Okay, so now we've got our timber, our first timber modelled in. We're just going to move that grid line over. Don't lock it in place. You'll see why in a second. We'll take this first timber and we're going to offset in the Y direction. So we wanted a 10mm plate in the middle, so we're going to offset it by 5mm. That moves it up there. We can then take this and mirror it around the grid line, and that sets that in there. We want to make sure that that is again locked to the reference plane, so you need to use that AL alignment tool to lock this second timber in place. Now for the steel plate, we go over to again structure, beam, and then select a plate, and then this one was actually, again, duplicate it. This was 225. Apologies if you can hear the ice cream van in the background here, it's summer holidays at the moment. 225. Okay, and we will put this straight down the middle, and again, AL, lock it to this reference plane. So always get the padlock and constrain it. like so. And now what you'll see is this length we can then change, and that's taken all those members together. So if we go into the 3D view, we'll now be able to see here's our one that we've just created here. So let's get rid of the example. It's now gone. We can get rid of all of this, in fact. That's now our Flitch beam there. The disadvantage to doing it like this is if you were to be using structural tags for your elements, it's not a single family, it's 3 separate beams modelled together. So if you wanted on plan to call it up with a tag, that wouldn't necessarily work. I mean, one option is you could maybe call these, rather than dimension number, you could copy this and create a separate family called Flitch Beam, for instance, just to rename it, and then just tag one of the timbers, or maybe just tag the plate and call the plate the Flitch Beam. So for tagging it's not very good, but in terms of just a quick and easy way without actually having to produce a whole new family and modelling that in, this I find is just the quickest and easiest way to do it. Normally then the Flitch Beam as well, you would drop that down at least 10 mil. Oops, sorry, minus 10. The reason being, particularly if this was being used for flooring, if you had floorboards or joists over the top, you can imagine the timber that's going to deflect, it's going to be compressed underneath the beams, but the steel won't be, and you don't want to end up with the timber kind of sitting directly on the steel when the timber either side is then shrunk or compressed or whatever. So you keep this below it so that you never have that instance, and your sort of timber to timber connection always remains the same. Anyway, thank you for watching. I hope that this has been useful. If you're finding this kind of content useful, then please do let me know in the comments. I'm hoping to get a few more videos out like this. And please do subscribe to keep a lookout for any more content in the future. Thank you very much. Bye.